Prior to moving to Suwannee, I spent 18 years at St. John's working on, 18 years working on lake, river, wetland, and spring restoration projects. I'm really excited about the opportunity to come over to Suwannee. Prior to that, I earned my doctorate at the University of California at Davis, working on pristine subalpine lakes. While I was asked to speak for the water management districts, these comments are mine and consequences are mine. I sent my draft to other folks I know at the water management districts and got some really helpful suggestions. I got one comment that really caught my attention was, ooh, delicate statement, may want to revise. I'll let you decide what that might reference. Today while talking about the health of springs, I don't want to get too worked up over a couple terms that are kind of loaded, impaired, harm. I'd rather talk about just generally about the health of springs. So when I talk about a healthy spring, what I'm really meaning is a spring that meets both its ecological and human needs. So I think when discussing spring's health, I think we have to look at individual stressors that can cause poor health to our springs. And just like people, springs can suffer the result of multiple sources of harm or ill health. These four types are water quantity, water quality, biological interactions, and disturbance. Each of these may or may not be present in individual springs. Within springs, they may vary in intensity, duration, and they may have interactions, most of which we're not going to fully understand. So in the few minutes I have to talk about springs' health, that would only begin to scratch the surface, so I want to focus on one component of most spring runs and use it as kind of a canary for our overall view of spring's health, and that's submersed aquatic vegetation, which I'll refer to as SAV. And I think it's important to focus on SAV in spring runs because it's the base of the photosynthetic community, it's the base of the food web. It also creates a refuge for the young and small. It's a source, a place for epibiota to live. And I would argue that if we create conditions where we have native, healthy SAV communities in our spring runs, we've gone a long way to protecting the overall health of our springs. The first stressor I want to talk about is water quantity. Now, in terms of the SAV, quantity has two aspects. One is just the actual wetted area and volume. How much could these plants possibly occupy? If we have a reduction in flows, we'll have a reduction in area or volume that's potentially colonized by these plants. The second aspect of quantity is velocity. The flow's velocity is important in a couple different ways. It moves nutrients around through the spring run, which is important for both the SAV's ability to take it up and for loss processes. It also helps scour the bed and the plants of attached algae and flush it out of the system. When these algae accumulate to either on the leaves or on the bottom, but particularly on the leaves, they can shade out the leaves so that they can't photosynthesize, and that's poor health for the plant. A similar sort of accumulation can occur within the water column of our spring runs when the flow becomes so low relative to the growth rate of the algae. When that occurs, planktonic algae can bloom within the water column. This is what we saw in the Santa Fe River last spring. Just like the algae that grow on the leaves of the SAV, they can create a shading of the plant communities, the SAV communities, and that can lead to poor health of the bed. Along the coastal springs groups, flow also plays a major role in lessening the impacts of salinity impulses and the approximately 8 inches of sea level rise we've seen in the last century. The determination of adequate water quantity is the responsibility of the water management districts. This responsibility is addressed in the district's minimum flows and levels programs. In short, the districts are required to evaluate the needs of aquatic ecosystems in terms of water levels, largely for lakes, and flows predominantly from rivers. I think we could do more thinking about how we manage that within the aquifer. For springs without runs, we look at the relative contribution to downstream water bodies, provided the base flow that contributed by the springs. For springs with runs, we look at both the ecological conditions of the run and its downstream implications. One important feature of MFL programs is that they are meant to protect systems from their in-place uses, such as recreation, caused by the consumption of water. They are not intended to limit changes due to natural variation in rainfall, hydrology, or sea level rise. These changes are beyond the scope of the MFLs and our own control. The challenge for us is that the separation of natural variability from consumption use is quite difficult and a moving target. The separation requirement has become more complex as we have learned of long-term cycles in climate that can have a significant impact on rainfall patterns. MFLs have been determined for some springs and spring runs. However, there are many currently under development and many more waiting to begin. One relatively new addition to the process is that if we determine a water body is currently not meeting its MFL, or that we project it won't in 20 years, we need to adopt the prevention or restoration strategies along with the MFL itself. So to specifically answer one of Bob's questions, yes, there are springs that need more water. Within the Suwannee district, we're finalizing the MFL for the lower Santa Fe, and are pretty sure that flows currently are not meeting that MFL, and therefore we will develop a recovery plan for adoption along with the MFL. Next, I want to talk about water quality. And the concerns for springs are often simplified to nutrients and often further simplified to nitrate alone. I think we should not exclude this consideration of other constituents, phosphorus, color, oxygen, from our evaluation of health, because it's not just nitrate alone. Nutrients, when applied to our gardens, yards, farms, or springs, stimulate algal growth. And as I've mentioned before, these excessive accumulations of algae are to the detriment of our SAB community. And combined with reduced flows, the interactions of the nutrients and flows are particularly unhealthy. The determination of water quality health in Florida is determined by the Florida Department of Environmental Protection, and Drew has covered the TNBL and nutrient criteria well, so I'll skip on to biological interactions. Interactions I want to focus on are interactions that create imbalance either because of the presence or absence or of changes in abundance that have ecosystem consequences. The best example I can think of in the springs is the Rodman Dam on the Ocklawaha. It restricts the movement of animals that used to move up the Ocklawaha and into the Silver River. Manatees, several species of catfish, mullet. And the loss of these grazers to the spring run has come at its detriment and to the detriment of those species. The responsibility for managing that lies primarily with the FWC, the Florida Wildlife Commission, and the U.S. Fish and Wildlife, although I think these issues can be addressed in a variety of other assessments and permitting decisions. The other biological effect I think we need to think about is the threat of invasive exotic species. There are a variety of species which have moved into our spring runs. Hydrilla excludes our SAB. non-native apple snails, armored catfish can all have consequences. And we've seen their impacts in a variety of springs around the state. The final cause of poor SAB health is human disturbance. Here I'm talking about people uprooting, digging up with their crops, with their feet, the plants. And I think the threat here is that because SAB grows more slowly than algae, that over time we can progressively replace our SAB with the algae, which more quickly can jump in and fill that space. I know scientists looking at the Ichthyophthys made recommendations for how we manage tubers and other recreational uses on the run, and those were put into place by the park. I think the districts have several important roles in addressing springs health. We collect lots of data. All these data are examined to look at how we examine the various aspects of poor spring health, whether we're trying to evaluate the cause of health or determine how well our remediation effort is working. We need good quality data. The districts also conduct a lot of research, sponsor scientific evaluations, and try and synthesize and become the local experts for the springs within their districts, and then work with all parties to come up with remediation, restoration plans that address all of the components of poor health. The district's actions can take on many forms that would benefit the springs. I'll name several, but not go into detail. Land acquisition and management. As was noted, the districts have bought spring runs, spring boils, and we're doing more in purchasing the spring, up in the spring sheds themselves, and working to put better ecosystem management in the spring sheds and work around the spring boils themselves to make it so that our footprints don't have such an impact. Our water supply planning is both for natural systems and people's needs. The development of MFLs and prevention and recovery strategies are one thing to manage the current pie of water, but our alternative water supplies look to make that pie bigger. We should be actively looking for places that have been historically drained, whether on the land or underground, to try and rehydrate them. We have regulatory efforts. Yes, we do consumptive use permits. It's, I think, probably the rare applicant that comes in and gets all the water they are asking for. Part of that process is to make sure that they're using the lowest quality water that meets their need, and they're using only the water they absolutely need, and they're trying to use it efficiently. We have a variety of cost share programs. Drew mentioned some with our agricultural WMDs. We do a lot of collaboration in Suwannee. We're so small. The Ichthyophthys and the Suwannee River partnerships are all focused on working on spring conditions. And these fit quite nicely into the district's core missions of flood control, water supply planning, water quality and natural system protection, and resource permitting. I can't meaningfully answer Bob's final question. The answer to how long will it take to fix my spring is based on the hydrogeologic conditions of individual springs. By this I mean the travel time from various parts of the spring shed. By the number and intensity of the various health stressors that spring suffers from. And of course the available restoration resources. I think it's also important to recognize that both spring and restoration ecology are so young that an adaptive management approach is necessary. We've got to learn while we do this and then do it better. I would not want to assume that our current restoration targets are adequate or that our current VMDs are the only tools that we will have tomorrow. This is particularly true for our new numeric criteria. Today's targets are what we think is necessary based on our current understanding, but I don't think they've been verified in real-world success, so we should implement them with lots of monitoring. In North Florida, there's a great deal of effort being put into consolidating the district's data so we can better better understand and manage cross-boundary groundwater issues. In these areas, Suwannee has defined water use caution areas, and while this cooperative work is underway, water use permits are often issued for only 5 years, so that by the time our research and other work is complete, these permits will be reevaluated with improved best available science. I'd like to end my thoughts on how the districts and all of us can be more effective. First, and this is a thank you to the Springs Institute and Bob. Let's keep talking and sharing our insights. Next, we should be vigilant in looking for opportunities to store water where it once was historically, in our wetlands, in our forests, in our aquifers. Finally, let's work to convert talk into action through development of comprehensive plans, identifying the role of each health stressor on our springs and the cures to make them healthy. This approach transforms the power of many voices and ideas to the persuasiveness of comprehensive planning, which those with the power of the purse strings find more attractive and likely to support. The marriage of good, well-intentioned ideas and resources will improve our springs. Thank you.
Have time for a couple of questions. Yes, sir.
Yes, good morning. Thank you, panel. My name is Marco Wilson from Citrus County with the Too Far Water and Natural Resource Foundation. I have a question and then an observation. The first question is with minimum flows and levels. The first question that I asked my district the day they came to our area and we talked about stressed lakes and buttresses and how we're going to know that they're stressed is, now that you have that information, then how will you address that? What is your fix once somebody gets slapped on the wrist because the water tables have dropped too low because of excessive pumping for whatever reason? I'd like that answered in just a moment. I also want to let you know that big money and water management go together sometimes, and it's not always a good thing. And I will give you a very unpublicized event that happened, I believe it was last year, the year before, in our strawberry industry in Central Florida. Water management had decided that it would be a good idea if they were to let those folks drop their wells deeper so that they could keep the water on the strawberries during time of freezing. Sounds like a good idea at the time. Unfortunately, the repercussions from that were unbelievable. It swallowed up entire towns, portions of the I-4 corridor, in a sinkhole. So sometimes water management, in trying to help, really did a bad thing. And again, I was amazed how little publicity that was put to that, as the taxpayers had to pay for all the rest of the things that had to be fixed. So I think what I'm saying is big business does have a louder voice. And those of us that are trying to save our springs, and it all comes for us out of the green swamp. That feeds 4 to 5 major riverine systems. And it's all interconnected because as we live across in the Withlacoochee on Lake Salapacachin, that water now comes into our lakes when we can get it. And then it also has been proven to be a major recharge for the spring system in Homosassa and Crystal River. It's all interconnected. So if we're pumping water too much and permitting too much of the green swamp area out there, we're not only affecting that area and that ground source, but we're also affecting 4 major riverine systems and a lot of springs included. These are the things that we've been looking at year and year and year and after. And we believe that that's something that really needs to be looked at, is how that permitting affects the rest of the ecosystem. Thank you.
Do you remember what the question was, Eric?
Sorry, I remember a bunch, so let me start and you guide me as I...
Yeah, just a short answer.
Sorry. Well, I think the issue on groundwater withdrawals and MFLs, first, in places where we can get people to use water more efficiently, we're working to do that. We've got a cost share with DEP where we're going out and retrofitting agricultural irrigation systems so that they use less water and what water they use is used efficiently. I think one place where the ag community and all of us who care about springs have a commonality is that they don't want to waste fertilizer. And so what they want is that fertilizer to be in the root zone. We want it there too. We don't want it leaching into our groundwaters. And a big part of keeping nutrients where they need to be and where they're useful is in water management. We don't want to flush those nutrients through. So I think there's definitely a need for better technology, better use in making fertilizer and water use more efficient. The other portion I would add is we need to be looking at making the pie bigger. I mean, it's hard to find places in Florida that haven't been ditched and drained to some extent going back 1800s easily. And we need to be looking for places where we can rehydrate the soils, because that's the water that's going to move down into our aquifer. So we really need to be looking for those opportunities to rehydrate essentially most of Florida. We also need to be looking at other bigger projects to capture and store more water so that the pie we're looking at is bigger. I know Swiftmud in your area has done that with the reservoir, and there's ideas in South Florida with using ag operations to store water. I think that's key, is to not think that we are limited to the water pie that we currently have. We need to be looking at how we make it bigger. I think the cross-boundary issues, I think everyone recognizes that the surface water basins that define the water management districts don't matter to the aquifer. The aquifer doesn't care. So I know there's an awful lot of collaboration going on between Suwannee, St. John's, and Swiftmud in trying to come up with a unified modeling approach, a unified understanding of the aquifer, because it is one aquifer. Sadly, it's also the same aquifer that goes up into Georgia and further up into South Carolina, and there we have a whole lot less influence. The management is even less protected.
I'm not going to take any more questions right now. I'll try to stay on schedule. Thank you very much, Eric. I got one announcement before the break. If you have not